Maria, Rose, Cena. These are the three walls in the Attack on Titan series. They're important. They shaped the whole series from start to finish. Some people hate them, others worship them. They're solid to stop Titans, and they're tall enough to prevent the Titans from bypassing them. But why are they round? Like, they could have chosen any other shape, a square, a rectangle, but for some reason, they chose to make them round. Now, technically, the walls in Attack on Titan are not perfectly round circles because the ground is uneven. But they're close enough. The walls have one purpose, which is to protect the people inside from Titans, right? Well, yeah, but they also have to be long enough to accommodate as many people as possible. And a proof of that is what happened in Season 1 when Wall Maria fell and people inside of it had to retreat to Trost District. As a result, famine spread. There just wasn't enough food for everyone. They had to send 250,000 refugees to try and reclaim Wall Maria. Of course, this was just a way to get rid of them and lessen the effects of famine. So, yeah, an important factor when building the walls is to fit as many people as possible inside. We know King Karl Fritz is the one who made the walls. He commanded tens of millions of Titans to create the three walls. The problem is, you have only a finite number of these Titans, so you need to line them in a shape that can fit as many people as possible inside. So what shape should you choose? Well, let's start by first formulating the problem in a more mathematical way. We have a fixed length, say L. And we want a shape of perimeter, L, and maximum area. It's called the isoperimetric problem. It's an old problem that dates all the way back to the ancient Greeks. They knew that the circle is probably the correct answer. They just didn't have any way to rigorously prove it. Throughout medieval times, we see some applications to this problem, like the map of Cologne and Paris during this time. But it is not until the late 1800s that mathematicians finally proved that, in fact, the circle is the shape that maximizes the area subject to a fixed perimeter. Now, the proof is a bit hard, so I can't present it here. But I would like to talk about some ideas that I personally find interesting in the proof. First, the shape must be convex. A convex shape is one that always bulges out, never denting inward. If our shape is not convex, this means there's some region that dents inward. We can just reflect this region around this line, thus creating a shape with the same perimeter but a bigger area. Therefore, if a shape maximizes the area, it should be convex. Second, the shape must have some sort of symmetry. Draw any random shape. Take any point on it and start walking until the distance you traveled is exactly half of the total perimeter of the shape. This means that these two shapes have the same perimeter. But if one of them has a bigger area than the other, we can just reflect it and get a shape that has the same perimeter as the original one, but with a bigger area. In a circle, this would never happen, as anytime you cut it, you get two shapes with the same area.